Hello viewers, welcome to the Raspberry Pi Programming in Proteus tutorial series, Episode 2. I hope you all are doing well. So, in our last tutorial, we have seen that how we can set up Raspberry Pi programming environment in Proteus and run a simple code on it. In this tutorial, we'll get into the real programming. In this tutorial, we'll see the pinouts of the Raspberry Pi board, how we can generate a digital output, and how we can read digital inputs using the Raspberry Pi. As you know, Raspberry Pi is a complete computer. You can do a lot using this device, but we'll just focus on the embedded system, the embedded part, in case we want to use it as a microcontroller or a microprocessor in a embedded system based projects. So in this tutorial, we'll just see how we can control the data flow in the pins that are provided in the Raspberry Pi. So let's get started. If you have seen the previous tutorial, you already know how to create a project in Proteus using Raspberry Pi, how to set it up. So I am just jump to the circuit building and the programming part. So for this tutorial, we'll need LED, a register, and after, when we'll be using the digital read function, then we will be needing a button, logic state, you can use it or not, a button, and we also need to reuse the register. So let's see how we can get these components. Click on here, and from here click on the P button to pick a device and see the component library. From here, just type in LED red. To choose an LED, you can choose any of these, and after that we need a register. Just type res, and from here select this res generic register symbol. The advantage of it is that we can set any value to it, and after that we'll be requiring a button. Okay, from here choose this single pull single throw button, the push button. Okay, now we need to build the circuit first. So let's put the LED here and the register here. Let's rotate it. Now we need a ground, so right click on your mouse and choose place. From here choose terminal and then go to ground and get it. You can also get ground from here. You are currently in this tab and click on this tab, so you will get the ground from here. Okay, now we need another thing, a connector. You will get this connector from the same tab, the terminal mode, and from here choose the default to get the connection. As you can see, we cannot directly connect these pins with the LED, so we need this connector. So what this connector does is it connects the pins with the same name. So let's say we want to connect the LED to the GPIO.BOARD or the Raspberry Pi pin 7. So in that case, you need to double click on it, and you have to put the name provided here. So we need to provide here GPIO.BOARD to connect the LED with pin 7. You have to spell it exactly as it is in here or it won't work. Okay, so the connection is made. Now we have to take a look at the Raspberry Pi pinout to understand how it will work. So as you can see here, we are using the Raspberry Pi 3 model. So this is the pinout of Raspberry Pi Model 3. Here you can see that it has two naming convention. One is the number of the pins on the board. It starts from this point. This is 1, 2, 3, 4 and continuous. So you can either use the pin number to control the output, or you can use the GPIO numbers to control the output. As you can see here that the pin number and the GPIO number does not match. uh, let's take this for example. Here the pin number is 3 but the GPIO number is 2. So when you are setting up, you need to be careful about this, which naming convention you're using. So I'll show you doing it using both convention. So let's get into programming. Uh, if you have created a project, you will see here another tab called the source tab. Let's get here. These are just my previous code. Let's clear everything. Okay, so first you need the time library, as we'll turn it on or off by a delay. So let's import the time library, and after that we need to import another library called rpi.gpio as gp. So the rpi.gpio, this library enables us to access the GPIO pins, and we are naming it as GP shortcut for rpi.gpio, so that we don't have to write this every time. It will be easier to write. Okay, so our import part is done. Now we need to define the pin name or the pin number. So let's say the pin name will be LED, and we have connected it to GPIO 4. So let's say it is 4. Okay, now we need to set the mode. So gp dot set mode. It means that we are telling the processor that which mode we will be using, the GPIO numbering system or the physical pin numbering system. To use the physical pin numbering system, you have to use gp.board. It means we are using the numbers on the board or the physical pin number. If you want to use the GPIO numbers, in that case you have to write gp.bcm. So first let's see with the physical pin number. So gp.board. After that you need to set the pin as whether input or output. So we want to turn the LED on, so we want to send the output signal. In that case we need to write gp.setup. So here it takes 3 parameters actually, but we will be using 2 parameters. The first one is the LED or the pin number we will be using, and the another parameter is its state, whether it will be uh, input or output. So gp.out, it means we want to use that pin for output. There is actually another parameter that is called the initial state. So let's say if you want to initially turn it high, in that case you need to write initial is equals to GPIO.high or GPIO.low, as you wish, but we are not using that in this case. That's optional actually. Now our setup part is done. Now it's time for defining the main function. Def main. Inside the main function, we will define a while loop, And while true, it means once we have executed the program, it will keep running until it is powered off. So while true, we want to set GPIO as GP dot output. First, it is same as the setup. First, you have to provide the pin number. In that case, it is LD, and its state GP dot high. So it means it will send a high signal or turn the LED on. And after that, we want to provide a delay of 1 second, and after that we want to turn the LED off. GP dot output LED GP dot low. Time dot sleep 1 second. So the LED will be turned on for 1 second and it will be turned off for 1 second. Okay, our main function definition is done. Now we need to create an execution point. If you have experience in programming Python, then you may know that it does not have any execution point by default. We have, if you need it, you can define it manually. So to do that, we have to write if underscore name equals main. So if the name of the function is main, it will execute from that point. If it's true, we want to run the main function. Okay, so our code writing is finished. So if we go back here, as you can see that this connection is connected to the GPIO 4 pin, but as we have used here the GP.board mode, so it will follow the physical pin number. So in that case it will be physical pin number 4. So where is the number pin 4? Let's say we want to see the output on this pin. The actual physical pin number is 7. So as we are using the board mode, so we need to name it as 7. Okay, now let's run this program. Okay, you can see that the LED is blinking every second. You may see a small lag here, that it may take more than 1 second or less than 1 second. Actually, this is simulation, this is not perfect. It has some lags or some miscalculation. It does not actually run with the proper timing. So we can assume that it is 1 second. It is turning at as 1 second and turning off for 1 second. So this was the digital output using the physical pin numbers. As you can see, the physical pin number is 7. So what if we want to use the GPIO numbering system? It's simple. You just have to define the set mode as GP.BCM, and here you have to put the number 4. This 4 means GPIO 4 as we are using BCM. So here it will now follow the GPIO system. Okay, now let's compile it and try it. As you can see, it is also working. And if you look here closely, that this pin is toggling, and so does the LED with this pin. Okay. So this was all about digital output. So I want to give a task to you. The procedure for learning is, if you learn something, you have to apply it. You have to try doing it by yourself, or actually you won't learn it properly. So there is a homework for you. If you want, if you can do it, and if you have any problem solving it, you can always ask on the comment section or contact me to if you need any help. So the problem I am giving you is you have to turn 5 LEDs one by one after one, and it will be turned off one after one. So if I just draw the circuit here, it would look something like this. Okay, so there will be 5 LEDs, and first this LED will be turned on and it won't go off. When it is on, after 1 second it will be 1, and after 1 second this one will also turn on and continuous. When all the LEDs are on, after that it will start to turn off from the beginning. So first this one will be turned off, after that this one will be turned off, and continuous. So give it a try. If you can do it, you have done a good job. Okay, so our digital output part is complete. Okay, now let's see how we can use the digital input functionality of the Raspberry Pi 3. For digital input, I have just used a simple button. Okay, we're placing the push button here, and we need a register. The value of the register should be 10K. Why we need a register, I'll be explaining it later. First, let's build the circuit. So you have to connect these two and this terminal of the register to the ground, and this terminal of the push button with a power source. As you know that this power means 5 volt, or you can use a 3.3 volt source also. So this is the complete circuit. Now we need to take the input from the middle where the register and the push button are connected. So we need a connection here, and we need to connect it here, and we need to name the pin where we want to take the input. So this is GPIO 4. Let's say we want to take the input on GPIO 5. So we have to name it as GPIO 5. Okay, so now why we actually need the register? Actually you won't need a register if you are using the internal pull up or pull down register functionality, but for simplicity we are using the register. So if you don't use a register, what will happen? Let's say you are pushing this button, so the 5 volt from this terminal, it will start flowing through the button to the GPIO pin. So it will give you a signal of high, but when you turn it off, the button may still read it as high, or maybe some unknown voltage in the range. So in order to prevent that and make it more clear, we connect it with the ground with a 10 volt 10k ohm resistor. So when you push the button, as you can see, there is too much resistance. So a small amount of current goes to the ground, but most of the current goes to the GPIO 5. And when it is off, the button is off, so this pin remains connected to the ground. So if we just turn on the simulation, as you can see that this GPIO, look here closely, let's zoom it. Okay, if you look here closely, you can see that the ground is denoted by a blue dot, and you can see a blue dot here. It means it is by default connected to the ground, or it reads it as 0 volt. So when you push the button, you can see the state has been changed to red. You can see here it is red. If I click it again, it is red. So it means when I push the button, this pin gets connected to the positive terminal, so it would read it as high. Okay, so what's the idea? What we want to do now? We want to push the button. When you push the button, this pin will go high, and when this pin goes high, we want to turn the LED on, and when this pin goes off, we want to turn the LED off. When this pin goes to 0. Okay, so let's go to the programming. We need to define another pin. Can you guess what will be the code for this? We need to change the pin number. It is button, and this will not be GPIO.out. Instead, it will be GPIO.in. It means we are taking the input, and inside the while loop we want to give a condition if GP, this GP means GPIO, the state of the GPIO button, GPIO.input, and here we have to provide the button number. So basically what we are telling here is if the button goes high, so if it is connected to the VCC, then this will return us true or 1. And as you know that when the if statement is true, it executes the code inside it, or else it does something else. So if the button is high, we want to turn the LED on. Else we want to turn the LED off. So the time function won't be necessary here. Okay, we are done. Let's check it. So let's press the button. As you can see, when I press the button, the LED remains on. If I leave it, it goes to 0. So it is that simple. Okay, so now I want to give you another task of using the digital input. So what will be your task? You have to take 2 push buttons. You have to take another button here, and as we have seen earlier, you have to take an array of 5 LED. You have to take 5 LEDs, and when you press the button 1, let's say this is button 1, when you press the button 1, the LED will start to turn on. First this one will be turned on, after that this one, and continues, and all of them will remain turned on in the on state. And when you press the button 2, all the LEDs will start to turn off and give a delay of 1 second. So first this one will be turned on, after 1 second this one, after 1 second this one, and when you press the button 2, the same. First this one will turn off, after that this one, after that this one. So give it a try. If you can do it, congratulations, you are doing well with the series. And if you have any queries or any problem understanding it, please let me know in the comment section. Thank you for watching. Please like the video and subscribe.